Hi, welcome back to Chemical Engineering Statistics. In this video, we will discuss about the basic concept of discrete probability distributions. This lecture will not discuss in depth about the mathematical aspect of the probability distributions, but will briefly introduce probability distributions for discrete variables. You need to read the textbooks to enhance your understanding. The probability distributions generally states the probability of the occurrence of each random variable x, which is a member of the populations. As an example is the dice below. The probability for each value to appear if we roll a dice is uniform, which is 1 over 6. So mathematically, it is stated that the probability of x equal to 2 is 1 over 6, x equal to 6 is 1 over 6, and so on. I have quoted another example from our reference textbook, example 3.21 on the right. Please look carefully at this example, which also includes the presentations of the probability distribution using the chart shown below. Let's take a look at few of the many types of discrete probability distribution. First is the binomial distributions. The binomial process, whose other name is the Bernoulli experiment, must meet the following condition. First, it involves a certain number of repeated random runs. 2. The result of each bet is only one of two options. It's fail or success, on or off, pass or fail, etc. Third, each run must be mutually independent, means that the result of one run has no effect on other runs. And finally, the chance of success per run is fixed. The box on the right are some examples of binomial process in the textbook. This is one more example of binomial distributions. The process is to complete a multiple choice exam with 100 questions numbers. Each question provides 4 choices, with only one correct choice. Of course, the output of each step of the problem is only 2. Either it's wrong or correct. If you take the exam without studying, your answer will be random variables, so the chance of getting correct is 25% per number. The binomial variable in this process is the number of questions you answer correctly, out of a total of 100 questions number. I copy this green box from the reference textbook. The quantity n represents the number of repeated run or trial. The Bernoulli process requirements are repeated in the green box. To express the binomial probability distributions, we can use the formula below, which states the number of combinations of the sequence of outcomes containing a number of x successes. Please learn more about example 3.27 in the book. The next is Poisson distributions, which states the number of random events that occur over a given interval. Well, this interval can be in the form of time, area, group, counts of number, and many more. The formula for the Poisson probability distributions as a mass functions is listed in this green box. The random variable x in this case represents the number of occurrences per unit interval. For example, the image on the left shows an inspection of a cannonball at an ammunition factory in America during World War II. The Poisson variables is the number of defective cartridges per a certain production quantity, say every 100 cartridges. The histogram on the right represents the Poisson variables as the number of unscheduled downtime events per year of nuclear reactors in the United States. Well, hopefully this video segment provides basic understanding for you to learn more about the concept of discrete probability distribution in our textbook. See you in the next video.